now suggesting other products for development outside the workplace market.
Sure, multimedia means different things to different people, but we have a couple different meanings for it. First of all, originally CD-ROMs were really a delivery mechanism, and that grew into multimedia because you can store so much on one of these little disks, about 500,000 pages of text, for example. So because you've got all this extra room on a CD-ROM, you're able to put on things other than just data. So it could be visuals, pictures, maybe even video, and also sound.
This is a computer program running, combining text, graphics, and sound samples, all played off the CD-ROM disc.
So that capability then has grown into the term multimedia. Usually means things that come like a title on CD-ROM, but multimedia itself is really the incorporation of sound and visuals as well as text in a computer program, or we usually call them titles or publications.
There's nothing necessarily magical about a CD-ROM disc other than it's a very big disc. Holds about 650, 700 megabytes of information. Because of that, you can do a lot of things. The world of entertainment and technology and information today is all digital, and because of that we can take that digital information and process it through the computer and provide information in a lot of different ways to somebody. So as you're sitting at your computer and you look at the screen, you can get sound, you can get video, you can get pictures, you can look up information, you can copy information from one program to another, and you're able to integrate the information in a lot of different ways.
What's the marketing idea behind multimedia?
Well, we're targeting very much multimedia use for the individual in the home, and since we're in the consumer software division, we think about what is it that people want in terms of content as they work in their home, not just necessarily on a computer. And so that opens us up to really any types of content. The best analogy would be the book publishing industry. So we're developing encyclopedia, which we shipped this year, that's online, as well as titles like musical instruments, mostly learning and information as well as entertainment. We've done an online movie guide, for example. So we think about what does a user in their home what are they most going to benefit from in terms of sound plus visual plus data text in a learning and entertainment environment.
The systems today that you're getting on your computer really do have a lot of capabilities. In the past, a computer was used for accessing information or manipulating information. That was really it. You could look up, you could create a spreadsheet or a word processing document. It was mostly text. More and more we're integrating pictures, sounds. Now we have full motion video that's available on computer. Because everything is going digital in the informational world, we really can integrate that into the computer to allow you to manipulate it and get it just about any piece of information you want to very quickly, very easily, and at the same time incorporate learning philosophies so that kids, for example, or even adults can learn in a very personal way. The personal computer becomes more of an information appliance, might be a way to look at it, rather than just a tool that sits on the desk.
Advances in microelectronics aren't confined to the traditional areas of information technology, computers. By the late 1980s, TV engineering trade shows were beginning to include research prototypes of advanced TV systems, which would offer bigger, sharper pictures to home viewers. The systems are known as high-definition TV, or HD TV, and they're expected to be in use by the turn of the century. Alarmed by Japanese work on HD TV, which had begun in the 1970s, a group of European manufacturers and broadcasters formed a research consortium known as Eureka 95. They exhibited the first working prototypes of their system at the 1988 International Broadcasting Convention in Brighton.
The picture of this screen was a full studio HD TV standard, recorded electronically. There was no film involved. Everything was electronic. And that gives you an idea of what's possible there. In a short while...
Their aim was to produce a large-screen TV system based on 1250 lines, compatible with today's 625 line systems, and capable of being distributed on satellite and cable links. Distribution is one of the biggest problems for advanced TV systems. The HD TV signal, unmodified, contains too much information to pass through undistorted. But using computer processing, redundant picture information can be removed, and the signal compressed to around a quarter of its original bandwidth. Of course, expansion is required at the receiver. To do this, considerable information processing power is needed, both at the sender and in the receiver. The Eureka system of the late 1980s is based on a mix of analog and digital technologies and has yet to come into the consumer market. One of the many problems yet to be solved is the design and manufacture of an acceptably priced receiver. Much of the problem lies in the display device. Conventional tube sets are very bulky, but the image processing is now quite possible to do using microchips. Since then, several competing systems based on all digital transmissions have been suggested, and perhaps there's the beginning of a large shift in the industry.
We've looked at IT in the workplace of the future. But what applications do you think people have in mind when IT is used in the home? Now we're going to look at things through the eyes of a telecommunications company. We're at BT Laboratories, Martlesham Heath in Suffolk, and we're in their idea of the home of the future. And we're looking in particular at their widescreen video display. BT's view of the future is an information-rich one. Fibre optic cable, presumably BT's, will have the bandwidth to deliver a choice of TV channels from across the globe, together with online access to interactive computers, and perhaps your own personalised video-delivered education. The mouse has escaped to the living room as a control device for the TV set come home information terminal. Apart from the large screen, they assume handheld terminals, which will double as cordless video phones. Whenever we deal with video technology, we're handling a vast amount of information. And BT's technical problem is the same as the one we've heard about before. They have to compress and process a huge amount of information so that they can transmit a video signal to and from your home. But of course, as you might expect, there's more to this than just a technical problem. Television, computing, and communications technologies are beginning to come together. The buzzword is convergence. And this convergence is opening up a whole new wide range of possibilities.
Television has been around for more than 50 years as an analog medium. Today we're beginning to see the advent of digital television. Today most camera and editing systems are based on digital technology rather than analog. With the advent of fiber optic technology, it'll be possible to have a pure digital path all the way from the broadcast center to the home. This will enable a whole new range of applications, ranging from random access to movies to home shopping and interactive activities, as well as the transmission of news and other information from broadcast centers to personal computers. We see a tremendous convergence between the devices that are thought of as television viewing devices to the personal computer. And there'll be very little difference in the future between the device that you think of on top of your TV set to control a cable television box or a satellite receiver to the personal computer or the game machine that you're used to playing with. This convergence, as it's spoken of, is really an attempt to get a certain overlap in the functions of the television set, this cable control box or satellite control box and the computer, so that you can get a much richer experience from all the media.
Perhaps one element of the rich multimedia experience of the future is to be found here at the QVC network near Philadelphia. QVC stands for Quality, Value and Convenience. They are a 24-hour live home shopping channel distributed over cable and satellite to over 45 million homes in the US. QVC pride themselves on being low-key, informative and soft sell. They have over 3 million customers, and in the first 3 months of 1993, the net revenue topped $270 million.
QVC basically is televised home shopping, and it's based on really the fact that a lot of technology developed in the middle 80s that allowed satellite transmission, the expansion of cable television in the United States, the advent of very high-powered 800 telephone network in the United States, and basically we took the concept of catalog shopping and expanded it to the live television media based on the premise that people could really see the products, see them demonstrated, get a lot of information in terms of how they work, why they're good, what their strengths and weaknesses are, that this would be a good way to service customers in the United States and provide them a different way of buying merchandise.
Okay, rotate. Rotate the set!
During a studio break on the hour, whilst a pre-recorded tape is playing on air, the set rotated to move the program on from the cookery hour to that morning's fashion show. Behind the remote control cameras in the main hall, banks of telephone operators sit at their computer screens, ready to take customer orders.
This kind of a business is very much computer technology based. We sell only what we have in inventory, so we obviously have to have very good inventory control. Our order entry representatives and our voice response units have to have instant access to what is our current inventory. The producers and the people running the show have to have instant access to exactly, where our product position stands. So that if we have, say, 5,000 pieces of a product, if we sell 3,000 pieces in the first 3 or 4 minutes, we will immediately pace our show to move on to the next product so that we don't use valuable airtime on products we don't have. Following that process, we keep track of each step of an order, from credit verification through delivery to the warehouse, through picking in a warehouse, through truck putting into a truck or put onto a manifest, so that at any point in time a customer can call in and get the exact status of their order. A third way we provide feedback is through a lot of historical, statistical evaluation of our customers' buying patterns. We have a parallel processing Teradata computer that is used very heavily by our marketing and purchasing people to look at customer buying trends and also returns, quality kinds of things on our products and on our customers.
So how do QVC view convergence in the information industry?
We see the distinction between telecommunications companies, media providers such as cable companies, and computer equipment and software makers basically all coming together into one set of devices that will be almost indistinguishable to the customer. We are obviously very interested in having the bandwidth into the home to allow true interactive shopping in the home by the customer. 3 major industries are spending lots of research and development money to try to develop the infrastructure and the devices to make this happen, and then they are basically the telecommunications, the cable, and the computer industries. The home of the future will have a highly interactive, full-motion device in the home that you might call a television, you might call a computer. It will be indistinguishable. So, we believe there will be a true convergence of the technologies, and there will be a convergence of the players, and I think you're starting to see that with some of the very interesting partnerships that are being formed between cable companies, computer suppliers, and telecommunications companies.
Already, the chip manufacturers are preparing to supply new products.
I hate to say it that way, but it's almost routine to be able to double and triple the power of the microprocessor. What is the most challenging is these new technology areas. How do you handle the communication interfaces, communication capabilities? Those are added capabilities that a computer platform has to have, and we have to provide that. We are basically a building block provider. We provide all the building blocks to make a complete product. And nobody would assume that it's a big deal to have a keyboard, but somebody had to worry about how you interface that keyboard to the computer. Now the same thing happens now in this new communication environment. Somebody has to be able to handle all that interaction with the real world that exists there in the communication environment. And by the way, that's a very changing world also. I mean, there are so many different ways to deliver bits. And if you want to make the computer a ubiquitous part of that environment, you have to be able to handle all those different ways. Whether it's a cable network, whether it's a telephone network, whether it's wireless. And within each of them, there are many differences and many permutation and combination.
This can, however, be more than just a technical matter.
This is a new world. It's like the beginning of the early phase of the microprocessor. We were looking at a device which could do all the variety of things that your mind's eye could see, but nothing really was there yet. Now, as we get into this communicating environment using the computer, there are a lot of constituents who never used to work with each other. Suddenly, these constituents, they own a little piece of that, but they have to start learning to work with each other. And that's quite challenging. That's beyond what technology difficulties you may have. It's really the telecommunication companies, the cable companies, the computer companies, and the people who create the source of information, the content companies, all have to start interacting in a way that they haven't done before. And that's quite challenging.
So to make all this technology possible, new partnerships must be formed. But to me it's interesting, it is we, the users, who don't seem to feature in the list of active partners. Remember that new technologies just don't appear by accident. They have to be formed by groups of people making decisions. Think about who the decision makers are in this case. Who stands to gain from those decisions? And who might lose?
Bases play an increasingly important role in modern supermarkets with their miles of aisles.
All these items are here in the supermarket, ready for the shopper to buy. They will have come from hundreds of different suppliers, but the supply chain has been coordinated so that each item arrives as and when required in the right quantities and to the right store. Safeway, the owners of this supermarket chain, make extensive use of a database system to govern their operations, from the moment a buyer places an order to the time it arrives on the shelf. This program is about database management. You are going to see how one organization, Safeway, uses its database system to support its activities. You'll look at how that system can be used by people with very different jobs to do, and at the facilities required by the database management system to support the evolving needs of the organization. We're going to start by looking at how the database is used to govern their entire operation, by looking at the supply chain, or how an item gets into a store in the first place. Safeway has 220 stores, each with its own computer. Each store puts together its own order for items. These orders are then transmitted to their head office at Hayes, home to the buyers, replenishers, forecasters, distribution and traffic staff who are vital to the supply chain. In Safeway, they use a relational database system called DB2, which stores the data in tables. Orders are broken down into order types, such as fresh food, and loaded into the store's order table, the biggest table at about 8 million rows. They have 6 order processing runs a day. These produce the picking notes, lists of the goods to be supplied, which are sent to each of their 20 distribution centres around the country. This is part of the distribution centre at Aylesford in Kent. And these are just some of the literally miles of aisles within the centre. Each of the aisles and bays in each warehouse has its own identifier, and the computer system maintains a map of stock held. Each picking location code corresponds to a particular item of stock. When a warehouseman starts to collect an order, he uses the picking notes sent out from head office. These will give him details of the picking locations he needs to go to, as well as details of which items are required and how many. The warehousemen work through their picking notes, collecting each item in turn, and eventually taking their stack of goods to the loading bays. The traffic staff at head office will have used the database system to schedule the collection and delivery of each order to the store concerned. But the replenishment operation is obviously going on at the same time. As orders are processed through the database, the buyers and replenishers at head office use this information to continually monitor stock levels and to decide how much to reorder from their suppliers and when. So, as these orders are moving out to the stores, there are these supplier deliveries moving in. Each supplier will have received an order generated through the system which will ask for particular items to be delivered to a particular distribution centre on a particular day, and even at a particular time. There are many people involved in the supply chain. For example, the buyers, replenishers and traffic staff at head office, as well as the staff here at the distribution centre. Their activities can be coordinated because they can all use the same data, held on the one database. All these people have different jobs to do. They possess different skills, they have different views of the data, and they'll certainly want to do different things with it. We're going to take a closer look at how the database can accommodate those needs. The database management system manages and controls the use of the database. Users gain access to the database by using the facilities it provides. We're going to look at non-programming users first. One of the ways they can retrieve information from the database is by the use of a query language. For this database, the language is called SQL. Queries can be written in SQL, which provide the users with the information they want. There are three kinds of such non-programming user. Casual users, who have little knowledge of the system because they only use it occasionally. Parametric users, who make regular use of the system by invoking predefined procedures. And general users, who know enough about the language to write their own queries. We're going to meet examples of parametric users and general users at Safeway. Steve is a stock manager at the Aylesford Distribution Centre. He's a parametric user. He doesn't need to know SQL or write his own queries. He does know how to run a predefined query, such as this one you saw earlier, in which he just inputs data to get the results he wants. In this case, stock picked and date. Mike Hickey is manager of inventory systems. He's a general user. He knows SQL, but he also uses a language called QMF, which is designed to make the database management system easier to use.
In the early days of QMF, we were actually writing a lot of ad hoc reports for people. People were deciding what information they wanted, and we went into the database to see if that was available and provide them with reports. Over the last 2 years, the information that's required has become more standard. Therefore, we have set those reports up as standard reports which come out over the evening or the weekend as production reports within the system.
Mike Hickey talked about can be found.
They don't realise they're running queries, and they just get an end result report on the screen.
We've seen examples of some non-programming users, but of course the database also has programming users who will be involved in writing user programs to access the database. The most significant of these being application programs. Safeway has separate teams of application programmers for each area of the business. We asked Nick Simmons, project manager of the warehouse systems team, to explain why application programmers are needed.
It's the responsibility of the applications programming team and the database administrators to design the tables that will support the required applications function. We would first of all design the table and then write applications code, normally in COBOL, and COBOL would invoke calls to the database via SQL. Those routines or programs would be written to go over the same function over and over again, rather than make a user develop a query or many different users develop the same query. The application team is responsible for a part of the business. In conjunction with the users, they would identify a business area that needs a computer development to help solve a problem. We would identify the functions that need to be computerized and the data that's needed to support that function.
Database users may access the database either using a facility of the database management system, such as a query language, or through the use of application programs. Database management is concerned with the control and use of data resources in an organization. So there are 4 key objectives for any database management system. Shareability. The data has to be shareable between different users. Availability. The data has to be available in a form suitable for all the different kinds of users. Evolvability. The data has to accommodate the changing requirements of the organization. And integrity. Organizational data must be quality data. It must be kept accurate, private, and secure. In practice, as in the system we've used as an example here at Safeway, many users may not be directly concerned with these objectives, though they would certainly be concerned if they weren't met. There's an important part of that database management diagram we haven't shown you yet, one that has a more direct involvement in achieving these key objectives. The database management system has 3 distinct interfaces, with non-programming users, with programming users, and with the database administrator, who establishes the database and sets up the controls on people and programs using it. We asked Stuart Snell from head office to explain the role of the database administrator.
The database administrator gets involved at the very early stages of a new project. He will be involved with data analysis, which produces data models of the structure of the data. He's concerned with controlling data redundancy. He's concerned with the access of this data, the security, and ultimately the performance of the database throughout the system.
The database administrator plays a key role in achieving the objectives of data availability and integrity. Colin Hock